see many people come in.
Yeah, I wanted us to hit the
We will
mark.
start at 10 o'clock, 5 minutes.
Yeah, 3 more minutes, then we'll start.
6 more minutes.
Yeah. Morning, people. Good morning. I see a lot of people are just waking up and joining.
I saw some people say they raised the hand last week and didn't get answers many times. So let me create a Google form for you. So for students, you want to ask questions, but you didn't get answered, you can use the Google form and we can answer the questions after the class.
Okay.
Is that good for you, Ide?
Yeah, okay, good. So if anyone has a question, you can fill your question in the Google form. And if I'm free, I will answer that question.
Yeah, fantastic. That would be great, Jeff. Perfect. Cool. All right, we'll start in a minute. We're close to 200 now. A lot of people are still joining.
Yeah. Okay, maybe we can start now. Hello, guys.
Go ahead, man.
Welcome to my class. And this is week 4. I'm Prof. And I'm the supervisor of community. And I come from White Matrix. About this week, we are going to discuss about the Solidity grammar and the smart contract. Last week, our CTO, Mr. Tim, had introduced briefly about the smart contract and the Solidity, but I guess some of you just not understand clearly and still feel confused. So at this week, I will talk about the Solidity grammar and the smart contract in detail, and we will do some practice. So maybe let's start today's class. Okay, following are the content of this week's class. The first part is about the smart contract. At first, we will make an introduction of the smart contract and about its characteristics, its capability, and how it works, and about its use case. And the second part, we will introduce about the solidity. I will detailedly introduce the solidity history and its variable data types and its variable types, and how to build a function and the detail about the function, like the function modifier, or and about the events, something like that. So if somebody still feel confused or feel unfamiliar with the solidity, just don't worry about that. I will talk in detail. Okay, so let's start with smart contract at first. In 1997, Nick Szabo proposed a conception of smart contract. The smart contract is just like a real-life contract, but in digital. And because it's based on the blockchain, so it has no need for the third party. And the other thing is, as some teacher just told you guys a few weeks ago, that the smart contract is based on the blockchain, which popular is BSC or Ethereum. So the smart contract has the same feature as the blockchain, like it can't be tampered with, and its store is decentralized. So let's discuss about the characteristics about the smart contract. The first thing about smart contract is it can be programmed. Every logic about smart contracts is programmed inside the smart contract, and the smart contract will automated execute the code that you code in if the condition was met. The third thing is about its enforcement. Because the enforcement is based on the blockchain technology, so you don't worry about whether the smart contract will be executed or not. As the Wu Xiao told you guys in the first week, that blockchain is a machine that creates trust, right? So you have we can make agreement between users that the smart contract can execution by itself. And the fourth things is about it. The smart contract are tamper-proof. This is also based on the blockchain feature, because blockchain are decentralized and are tamper-proof, so it cannot change by every single people or single node. And here we are going to talk about the capabilities of the smart contract. The smart contract can automate it process because it's based on the blockchain. And once you deploy your smart contract to the blockchain, you have no need to manage it or just like put it in your own computer. You have to manage it, right? But if you put the smart contract on the blockchain, it will automated process. It will be an automated process. And the second thing is it can ensure the security. The security is ensured by the decentralized and the blockchain technology. The third thing is the smart contract can reduce the relations to middlemen. If something that related to the middleman, it will cost more. It will take some fees, right? And the third thing is a smart contract can manage users' agreement. This part I have been told in the earlier slides, so I won't repeat it here. And last, the smart contract provides utility to other contracts. About this part, if one smart contract provides the visibility like public, and it provides a function that can be used by other contract, then other contract can just use the function that has code in some other contract that they want to use. So they can just use each other's function. And then I'm going to talk about how smart contract works. So smart contracts runs in the blockchain, and smart contracts contains a lot of rules. So if you deploy a smart contract on the blockchain and someone just trigger the condition, then the smart contract will be executed. That's the whole process, how the smart contract works. And now I'm going to talk about the smart contract anatomy. About the smart contract anatomy, the smart contract is open source, right? So everyone can see the smart contract code. There are two advantages of these things. The first thing is if anyone can just check the code of the smart contract, they can know how it works and its usage, right? They can know in detail about its code, so it can make people to believe in about the smart contract. And the second thing is if the smart contract can be checked or verified by some other people, the security of the contract can be verified. So the contract is, the more security that where the contract have. Okay, about the smart contract use case, I think smart contract can be used like everywhere. So if like Amazon use smart contract for the supply chain management, and I think Facebook create its own smart chain called Libra, right? And many other companies just use smart contract to do some different things. I think if the blockchain can provide the enough transaction support, every traditional transaction can be migrated to the blockchain. So don't worry about the use case of the smart chain. Okay, after the smart chain part, I'm going to introduce about the Solidity. Okay, the Solidity is the programming language of the smart contract. As you know, there are many programming language of the smart contract like C++ or Go or JavaScript or something else, but the smart contract is the most commonly used programming language in the world. Smart contract is an object-oriented and high-level programming language, which means it can use the class characteristic and inheritance. So, and the library, I guess. So with this kind of programming language, it can achieve the complicated function. And the smart contract is derivative or influenced by the C++ or Python and JavaScript. And its design target is to make a service for the EVM virtual machine, which means EVM. So there are some unique design to serve the EVM. And also, Solidity is a statically typed language, which means every single type variables that should be declared when you are programming the code. And the other thing is, before you deploy the program, you should compile it first, and everything will be settled down when you compile it. So with Solidity, you can do many things with Solidity. You can build a voting program or a crowdfunding program or some information change program or something like else. So there are many things that you can do with Solidity. Okay, about the right picture is the Solidity icon. And at the left, I just show an example of the Solidity file. There are several parts of the Solidity file. I will introduce about them one by one at the following slides. Okay, at first, I'm going to introduce you guys about compile version settings. So the Solidity file uses pragma keywords to define the Solidity compile version. There are 3 ways to define the compile version. I made the syntax at the right. The first is we can define a specific Solidity version. Like if we want to define the Solidity version is 0.6.0, so we can directly just write the 0.6.0 here. So with this line, this Solidity file will be compiled by the 0.6.0 compiler. And the second is if we want this Solidity file can be programmed in a range version of the Solidity compiler, then you can set like this. With this topic, we can set this file compiled by a range compile version, which this sentence means this file can be compiled by the Solidity compiler more or equal than the 0.6.0, but less than 0.7.0. And the third way is the easy way that you can understand, because it's use an operator to limit the Solidity compile version. So with this, this file that can only be compiled by the Solidity compiler more or equal than the 0.6.0, but less than the 0.7.2. Okay, and like other programming language, Solidity has different data types, just like C++, because if we want to store different type of value, that we need to use different data type. Like if we want to store a string value, that we need to use a string data type, right? The first data type I want to introduce to you is integer. Okay, there are two types of integer in Solidity. The first type is signed integer, and the second type is the unsigned integer. The signed integer can store the value of positive and negative, but the unsigned integer can only save the positive value. Not only the difference with signed unsigned, there are some difference with the length. So if you want to declare a 256 bytes variable, you need to declare it as uint 256, right? But if you want to declare an unsigned int with 8 bytes length, then you need to define it at like uint 8. The different legends have some difference. So if you use the short length variable, then you will use less gas fee when you change it. So when you define a variable, you need to take care of two things. The first is unsigned or unsigned, is signed or unsigned. And second thing is about its length. I take an example here. Maybe you guys can learn it by yourself. Okay, the second type is the Boolean. Okay, the Boolean is the type that stores true and false. And this is a very commonly used in our daily programming. So the Boolean variable can be operated by the logic operator. And the logic operator like logic negation or logic conjunction or logic disjunction. So there is a syntax. When we want to define a Boolean variable, we use the bool keywords. And we can use the bool keywords and following by the bool names, bool variable name, and we can assign the bool variable by true or by false. And in the below program, we can see there is a yellow part right here in the quote. We defined a b. We defined b equal to 10. So if the b less than 20 is true, then this true is a Boolean variable that will return to the if function. Then the if function will do the following codes. we execute the following code. But if the b is not less than 20, then it will return a false to the if function. Then the if function will do something different. So, okay, the third thing is about array. When you want to define or store a collection of something, and those something is in the same data type, maybe we will use the array data type. The array data type have two classifications. The first is the fixed array, and the second is the dynamic array. So the fixed array means the array with a fixed length, and the array should be defined by a type and its length. And the dynamic array, which means it has no fixed size. The dynamic array was controlled by the push and the pop function. So when we want to define the array, we need to use the type of the array and with a middle bracket. If you want to define a fixed array, there should be some number in the middle bracket. But if you want to define a dynamic array, there should be empty. Okay, then we just discuss about the enums. The enums is a restrict to one of only a predefined values, which means predefined values. When we want to define an enum variable data, that we should define an enum data type first, like we code in the syntax. At this example, we just defined an enum called gender, and the gender has three options. The first is male, the second is female, and the third is I prefer not to say. So if you want to assign the enum variable, you should choose one of these one of the three value in these predefined values. So you can choose male, or you can choose female, or you can just choose I prefer not to say. So the enum can be used by the choose of some predefined values. Okay, then I'm going to talk about very interesting is the structure. At the above slides, I just talk about array, right? If we want to store some collection of the same data type, then we will use array. But if we want to store a correlation of different data type, what should we do? The Solidity provides a solution that is structure. Okay, if we want to store the student information, the student will have a name, right? It will have an age, or it will have a gender, it will have a dress, or something like that. So those information are different data type, right? So if we want to store a student information, maybe we can use the structure. The structure data in the Solidity file should be defined by the struct keywords. And we use big parentheses to define the struct. We can put some variables that we want to store in the student information in the big parentheses. Like here, we put an integer, and we put a string, and we put an uint. So if we want to store something that's a different type of the declaration, we can use the structure. Okay, here is a very interesting things of the Solidity. Solidity provides a structure named mapping. Mapping, in fact, is a hash map. It's not like array that have understripped. The mapping use a structure of key to the value to locate the value. Like here, we have example. We defined a variable named user level, right? User level. We need to know which user has what level. So the user level is defined by the address. Address is the key type, and the uint is the variable type. So you can search or define the user level by the user's address. Like this, we set a function which name is set current level. We want to set some user's level. So we defined, we code here. We assign the level to the user level. This is a mapping variable, and in the middle bracket, we fill in the user's address. So after this sentence, the level just store in the position of the user's address in the user level mapping variable. Okay, so we store at first, but what if we want to get it out? It's the same way. We can see here, there is another function. We want to collect the level that we just stored in, right? So here we put we just input a user address at first, and we use this user address to search for the level that it's stored in the user level variable, and it will return the addressed corresponding level. Okay, that's how it works. And we just talk about address, right? Address, in fact, is a unique conception of the solidity because of the structure of the idiom. So address means the account of somebody, right? So if you want to transfer the money from one account to another account, you need to know about its address. So address has a very specific data limitation. It should be 40 characters, and it should be start with the 0x, right? So if you want to define an address variable, you should use the address keywords. And the address variable has some different things. Address variable is, in fact, when you define address variable, it can use some global variable feature like this. You can use a dot balance to use is a balance function. It will get its balance of this account. And you can use transfer to transfer the money from one account to another account. So address, in fact, is a very innovative creation of the Solidity. Okay, and here is the comments, right? Comments is just like in every programming language, we use comments to write down some text information about the code or about the project. So we want to use comments to let the program to more readable. If you want to comment something, at first you can use a double slash. A double slash is used for a single line comment. And if you want to make a long comment, a multiply comment, you can use a slash and with asterisk hash. I don't know how to call it. Okay, you can use this sign and a slash. So with this, you can define a multi-line comment. So here is an example of how to define a comment here. And with every example or syntax, you can see some blue word here, right? Okay, this is a reserved word for the Solidity language. You can't use those reserved words to define a variable name or something like that. You need those part is used in the Solidity programming. Okay, after the data type, okay, here we are going to talk about something about the variable type. What's variable type? So variable type is connected with where the variable will be stored. If the variable stored in the blockchain, it will be the state variable. Like if you declare the variable and you want it to store on the blockchain, then you should declare it as a state variable. And if you don't want it to store on the blockchain, and if it's just used in some function, you can just declare it as a local variable. So if you change a state variable, it should cost some fees. But if you just change a local variable, you don't have to cost for that. So there are some state variables syntax. If you declare a variable just outside of the function, but in the contract, it will be a state variable. But if you declared a variable in the function, then it will be the local variable. Besides the local variable and state variable, there is another kind of variable, which name is the global variable. The global variable contains some blockchain information. So you can collect the blockchain information by using the global variables. Like I take a picture here. You can use the block difficult to collect the block difficult of the current block. Or you can use the gas limit, this block dot gas limit, to get the current block gas limit. So this kind of variable is widely used when you want to collect some information of the blockchain. And here I'm going to discuss about the variable scope. Variable scope of local variables is limited to the function in which they are defined. But the state variables have three types of scopes. Three type is public, internal, and private. So this scope defines where you can use these variables. Like if you define the variable of public, then you can use this variable in the contract or in other contract. You can use it both. But if you use the internal scope, then you can just use it in the contract or its inheritance. And if you use the private scope, then you can just only use it in current contract. So the variable scope will influence the area that the variable can be used. Okay, here I'm going to talk about the operator. There are many operators in the Solidity language. We can just classify it to 5 classification. The first is arithmetic operator, which is about the math. It will be like minus, plus, mod, or power, something like that. So we can use arithmetic operator to operate the integer variables. And the second is the comparison operator. The comparison operator can operate the Boolean variables. And also is the logic operator. The comparison operator can also can also used for the integer variables. Second is the logic operator. The logic operator I just mentioned when I talk about the Boolean variables, right? The logic operator is commonly used to operate the Boolean operator. Like you can use AND if there are two true. If there is an AND between two true variables, then the result will be true. If you use an AND operator, okay. So the fourth operator is the assignment operator. The assignment operator is to assign something. Like if you want to assign A for something, you can A equal to 1, then you assign 1 to A, okay. And the fifth operator is a condition operator. You use a question mark to achieve a function like if. You put one condition after the question mark, and if the condition met, it will execute X, and otherwise it will execute Y. Okay. After the operators, I'm going to talk about the control structure of the solidity. The first things I'm going to talk is about the loop. Okay, the loop is, there are three types of the loop in solidity, is while and do while and for loop. So I will introduce them one by one. The first thing is the while loop. Okay, if you want to execute some statement or code that will repeatedly as long as an expression, then you can put the code in a while loop. The while loop will check the condition first. If the condition is met, it will go inside the while loop and execute the code in the big parentheses. But if it's not, it will come out and just skip this while loop and just execute the code following. The second is the do while loop. The main difference between while loop and the do while loop is the while loop will check the condition at first, and the do while loop will check the condition at last. Like this, the do while loop will execute the statement at first and then check the expression. If the expression is not met, then it will just continue and do not come back to the do and execute the statement and do not execute the statement repeatedly. Okay, the third classification of loop is the for loop. The for loop has three important parts. The first is the loop initialization, and the second is the test statement, which is the condition that when the loop will be end. And the third is the iteration statement. Okay, at first, before a for loop start, you need to initialize about this variable. Like here, okay, we defined an int variable, which name is I, and we initialize it with the 0, right? And the second thing is when will the loop execute? If I is less or equal of 10, then the loop will be executed. This is a condition of when the loop will be executed. Okay, the third is the iteration statement. The iteration statement, which means after every loop, the iteration statement will execute. Like here, after every loop, like after the first loop, the I equal to 0, right? But after the first loop, I were +1. So at the second loop, the I will be equal to 1. So that's the iteration statement. So I just talked about how many loop classification in the Solidity. And now I'm going to talk about how to skip the loop. If you want to skip the loop for once, or just skip this iteration, or just skip the whole loop, there are two ways to skip. The first is a continue. If you want to skip just this iteration, and it will come back to the beginning of the loop. So when you want to skip this iteration, you can use the continue. But if you want to just come out of this loop, you can use the break. And when the programming execute to the break, it will come out of this loop. Okay. The third thing is about the if-else. Okay, the control structure. The if-else control structure is about how to do the condition choosing, right? Like if we want to choose the condition that A met here, we made a syntax. We want A more than B and A more than C, then we will execute that result equal A assigned to the result, right? But if this requirement is not met, then it will come to the else. And there is another if after the else. So it will just check, oh, this condition is met or not. And if this condition is met, then it will execute this. But if it's not, then it will come to another else that corresponding to this if. So if and else is a structure that do the condition checking. Okay. Okay, so here is a very important part of the Solidity. It's about the function. The function is a group of reusable code. Like if you want to define the function of add, you want to input two variables and you want to add it and come and just output one result, right? If you want to do this repeatedly, then you can just define the function. So if you want to do something that's repeatedly, or the function will be used to a lot of where, then you can define the function to do those things. The advantage of a function is you can depart the whole contract to several independent functions. It will easily to management the whole contract. Okay, like I just show here, I have a syntax of the how to declare a function. When we like to declare a function, the first thing is we use the function keyword to declare it, and the following is the function name. Then we use a quote. Inside the quote is the input parameter. And then we will use some modifier and the visible modifier like public or view or pure I will introduce in later slides. Okay, and we will use a returns if we have some output parameters. If not, then we just skip this part. Okay, the function is a reusable code part, right? And this constructor is some kind of function, but the constructor will just invoked once when the contract is deployed to the blockchain. So the constructor will only be executed once. If you want to do something when you create the contract, just fill in the statement in the constructor. And here is the syntax of the constructor. The constructor's visible should be public because when you deploy something, then the others will use this function. So the function's visible should be public. And if you have some statement of the constructor, just fill in the big parentheses. And we talk about function, right? But I haven't talked about how to define the modifier of the function. The function have two modifier in Solidity language, like pure, three modifier in fact, like pure and view. The pure function is the function that will no use of the gas and no return. So the pure function will just do some calculation on the EVM. The pure function disallows the modification or set of the state variable. So if you change any state variable in the function can't be the pure function. There are several limitations of the pure function in the following. So you guys can check if the function just met these limitations. Okay, the second is the view function. The view function is the function when you want to return or you want some output that you can read, you can use the view function. Because if you use a view function, you will see the feedback in the React window on the website. And the view function still disallow the modification of the state. Like I just said, it can't change the state variable status. And there are still some limitation of the view functions, like you can't modify the variables, you can't emit events or create other contract like this. Okay, the pure and view is the modifier that defined by the Solidity language. But if you want to define some modifier by yourself, you can use the modifier keywords. The modifier keywords provides a way that every coder could modify the function by themselves. Like here, we want to define a modifier that the function can only be used by a specific person, like who create the contract. How should I achieve that? We can use the modifier keyword to create the modifier. And it has name like only owner. And we use the require function to make a condition, which is the message sender who creates this transaction should equal to the owner. The owner can be the one who creates this contract, or can be some address that who own this contract, right? So with this modifier, the function can only be used by a specific person. The modifier is automatically check. The modifier can automatically check a condition when you want to execute a function. So it helps a lot when you are coding. I just talked about the visibility of the variables, right? And now I'm going to talk about the visibility of the function. I just introduced you guys about the public, internal, and the private. It's the same as here. And there is one new one called external, which means external. External means if this function visible is external, you can only use this function in other contract, not on this contract. If you use an external function in the current contract, the compiler will give you an error. So if you want to define some function visibility, just be careful. Okay, maybe we'll come to the last of the introduction of the Solidity. Solidity is designed for the EVM, right? EVM is not like our own computer. If we program on our own computer, we can just use like print or like count to output the log, right? But if we want to check the program executing status on the EVM, what should we do? Okay, so Solidity provides a solution, which is events. The events will store some output of the status of every function. Like if you define an event which name is high speed increased, if you want to record some high speeds, you can use this event to record, and you can define some variables in this code. You can define like the bidder's address. Okay, the high speed is how much is it? Okay, so you can use a uint to define it, and you can use an index. You can add an index here. So if you add an index here, the people on the EVM can just search these events by the index. And after you define the event, you can use it by the emit keywords. You can put an emit sentence in a function. Then when the function executes this emit sentence, it will send a log to the EVM. And after this process, the people can search for the log on the EVM. With the events, people can understand the status or can listen the status of the contract, and can be easily to adjust it or just make some adjustment. Okay, here is the whole part of the introduction of smart contract and Solidity. So I'm going to make an example how to build a smart contract from start, and maybe it will help you guys to finish this week's assignment, right? Okay, as I said, we open the chain BSC IDE at first. And we can create a new project, maybe. Okay, we create a new project. So at first, we come to a new project. We need to create a file at first. We create file by selecting this button. Okay, then we can just fill in our file's name, like assignment 1. .sol, because the Solidity file should end with SOL. Okay, as I just talked in the slides, the first things about the Solidity file is we should define its compiler version, right? When we want to define a compiler version, okay, we can use the pragma keywords and following by the Solidity. If you print the code correct, those words should be blue, okay? And I will use a range version like 0.6.0, okay? Okay, this means this file will be compiled, use the compiler more or equal than the 0.6.0, but less than 0.7.0. Okay, so I will set a comment which when I want this Solidity file is about how to store student information. So if I want to store student information, I will use the data type that structure, right? Structure. So the first thing is we will build a structure. Okay, and we will use this structure to store the student information and retrieve it. Okay, so I will make a contract at first, create a contract, right? The contract created by the contract keywords and the following by the contract name. Okay, I will use the test maybe. Okay, and here I'm going to create a structure variable, right? So I will use the struct struct. Okay, the struct name is student. Of course, this struct is used for store the student's information. Okay, we'll use a big parenthesis to store the struct information. And the student will have some characteristic like number. If we want to store a number, okay, we will use the uint. The uint is equal to uint 256. So we will define the uint variable at first, and the name should be number. The second is maybe about the student's name. If we want to store name, we will use a string variable maybe. Okay. And the third is if we want to store a student's gender maybe. Okay. If we want to store a student's gender, maybe I can use a bool. Is male or not. Okay, here, let's finish the creation of the structure. But if we want to create a structure variable, it's not the end. We should create a struct variable. So we create a structure first, right? The struct name is student. And if we want to create a specific variable, then we should code like this. The first is we type the student. And we're following by the variable name, like the first student, okay, student 1. Okay, here I just declared a struct variable. And I'm going to set the information of this student 1, the first student variable, okay, the function. I have to declare a function, unction. The function name is set information. Okay, and it's following by a quote. In the quote, we should fill in the input parameters. The student information includes 3 parameters, right? The number, the name, and its name. So I will put it inside here. uint. And the parameter is used inside the function, right? So it's a local variable. If you want to use some local variable, I prefer to use an underscore here. And the same name, number. Okay, the second thing is the name. It type is string. When you want to input something and make an assignment, the variable type should be as same as you just declare in the structure. So as the same things, I just declare the 3 variables here. So when you want to use this function, you should put 3 input parameters inside the when you want to use it. Okay, the second thing is the visible of this function should be public, right? Because if you want to use it, it should be called by the interaction of the contract. So everyone can call it. So the visible of this function is public. And maybe, okay, that's the end. Okay. So inside the function, we need to code the statement. The statement is we need to make an assignment of the first student variable. Okay, student first number equal to number, right?
Hello.
And hello.
Yeah, so sorry to cut you short. But some users are, some students are asking that you zoom your screen a little bit. The characters are very small.
My character is too small. Like if I,
this is better.
This is better. Okay.
I hope you can see it now. Chat if you can see it. Yes or no.
Okay, I can just check.
Aha, I think it's bigger now.
Okay.
Go ahead, please.
So I have set the number right. The second is the name. So I just put name here, and the assignment, the underscore name variable to the student first name variable. Okay, the third is the bool variable, the Ismail, right? Okay, student first. Okay, and one thing that we need to remember is when you want to use an array or a mapping or some reference type of the variable, then you need to declare the variable is stored in the memory here, or the compiler will just return error to you when you compile it. Okay, this is the set information process of the when you want to store the information of the student first. Okay, so when you interact with this function, then you set the information. And the second thing is you want to retrieve the information. Okay, so let's define the second function, which is the here. So in the get information, we have no need for any input parameters because there is nothing that we need to input. Okay, and the visible of the function should be public because we need to interact with it, right? Okay, and the third thing is we need to define this function with the view modifier because we want to see the result that this function returns. So if we want to see some result of the function, we need to set the function to the view modifier. Okay, and we need to define the returns parameters. The first is the same as those. Okay, we can just define this type here without its name, or you can define its name too. Yeah, it's okay. So after this, we can use the return keywords to return the structure value. Student first dot number. Student first dot name, and the student first dot Ismail. So we finish here. Okay, after this process, we just finish the coding. So we need to compile first. Okay, we come here, and the compiler should match this requirement, right? So 0.6.12 is fill this requirement. So we can just click the compile assignment, click it, and wait for a few seconds. oh, something wrong. Okay, I just forgot this memory here. If you face something error like here, you can if you face something error, then you can see the details about the error. Here, it points out that there is something wrong with the 20 lines is here, right? And the 57 character. So as I just mentioned, if you use the string or some reference type like array in the input or output parameters, you should add the memory here. Then, okay, then maybe you can compare success. Okay, so now we can deploy this contract. Okay, let's wait for minutes for its deployment. Okay, it's success. So the first things of the contract is we have to set the information at first, right? So the first thing is we need to set this number. I guess the number could be 1. Okay, the window here will hint you what kind of value that you should input. You should fill in. Like here, you should fill in a string value, right? String value. So maybe and the third is you should be a bool value. Bool value can be true or false. Okay. So after you fill in all of the form, then you can just click the submit. Okay, it's success. And now the information has been stored in the blockchain, and you can just retrieve it by this function, get information. You can click the get, okay? And here is the number and the name and the gender, okay? So this is the whole process for creating a contract. I hope this process can help you to finish this week assignment. At this week, I will give you guys 2 assignments. One is about how to set and retrieve the value in a mapping variable. And the second thing is about how to make a modifier, which is the creator of the contract can only be used. I want this modifier can only use can specific condition that the function can only be used by the contract creator. Okay, so I will list the details about those 2 assignments on chain classes maybe. Okay, those the full contents of today's masterclass, I guess. So I will check about the Q&A part, or yeah, hoster. Hi, can you listen to me? Okay, maybe I will check. Okay, I will check the question part. Yeah, okay. At first there will be a recording of this class, of course, yeah. Please can a smart contract on testnet interact with one on the mainnet? No. I guess at this environment, the mainnet and the testnet are independently. They can't connect with each other. So then how can someone test a contract on testnet if the smart contract is called function on the mainnet? I guess there is no way, or you can just copy the same contract from the mainnet and put it on the testnet, I guess. If the EVM is an isolated environment running in the node, it's not isolated, I guess, because the EVM is closely combined with the blockchain. Okay, all of the node and the block create one EVM. Okay, they just provide the basic resources like calculation and the storage of the EVM. Did the chain ID allocate a safe project to user wallet by using map method? Really interesting to know how user data can be stored without your KYC. Okay, the chain ID will storage your data. Not chain ID won't storage your data. You still your contract data will just storage on your Chrome file system. So it will on the Explorer, not on chain ID, not in chain ID. Okay. The maximum length of unsigned integer is 256. Okay, the OP codes. Okay, can you explain the OP codes? OP codes is if you code with the Solidity, right? Solidity is a high-level language, but if you want the EVM to execute the language, it can't execute the Solidity. Solidity must convert it by compiler to the OP codes. So OP codes is a language that EVM can read. Different color, which means different color. I guess there are just, okay. The white color is the common variables like variable names or some, like if you defined a structure here, the struct will be the reserved word, but the struct name won't be. So the name will be the white part. And if the part is blue, then it should be a keyword like function, okay, like uint. Those are the keywords of the Solidity. And about the green part, I guess, green part is the comments. Those comments won't be compiled by the compiler, okay? So if you see some words in blue, then it won't be compiled. Okay, you can use enum for the gender selection, or I just, because I think maybe some of the students need some simply explanation, so I use bool here. Maybe I can explain an example of modifier. Okay, I will make some example here to explain the modifier. Like here, okay. If I want to create a modifier, first thing is we need to use the modifier keywords, right? Okay, and we need to specific the modifier name, like if we want this modifier to just used by specific address, I guess. Okay, so I will use the syntax that I put in the PPT. Okay, in the only owner, okay, I use the requirement. I require. Okay, require keywords to set some conditions like the message sender. Okay, what is message sender? The message sender is the one who creates this transaction. Like I interact with the contract, then I will be the message sender. Like this address will be the message sender. Okay, so equal to the owner. Then who is owner? I don't know who is owner. Anyone can be the owner. Okay, I will do and I will maybe I can set owner here. Okay, owner is the address. Okay, anyone can be the owner. But if you set this owner value to some specific address, then this and you use this modifier, then you will this function can only use my specific address, I guess. Okay, so I will explain this part about this underscore. Is it on behalf of the sentence that the in the function, like this underscore on behalf of this part. I can say that. So if you want to use this only owner and to in the set information, so you can just put it here. Okay. So after the visibility, you can use the modifier to modify this function. Then, and compile and deploy it, then this function can only use by a specific address whose name is owner. And you can set this value on other function or on the constructor. You can do that both. Okay, maybe I will select 3 more questions. And if you have another questions, you can just fill them in the Google Doc, I guess. Can I explain the mapping again? Okay, about the mapping. Mapping is a hash map structure data type. Like one is a key and the other is the value. You can use the key to search the value. Like you can search some home. There is a map. Okay, there is a map that you have, and like I have a Wall Street first building. You know this address, right? And you can find the building by this address on the map. So that's hash map, I guess. I can tell you like this. How do I get ChainID working on my computer? Okay, ChainID is an online compiler environment. So you can just log in the website and use it. No need other things. And maybe you need to have a wallet plugin. You can use it on Chrome. The Chrome has MetaMask or Binance Wallet or some wallet plugin. So with this basically requirement, you can use ChainID just directly. How do we retrieve the get information data from another function? You can just put the get information, this function, just put it in another function. Just use it. Like if you want to put it here, you can just get information. You just put like this, and maybe you can equal to some A and B and C, maybe this. Yeah. How do we connect the front of application to blockchain? Is there some kinds of connector? Yeah. If we want to connect the from and the end, we can see the EVM as a computer, right? But it's a backend computer. So you code with Solidity on EVM, and your code is running on EVM, but it's a backend. But you want to interact with it and make a page. So you can use JavaScript or React or some structure to build a homepage, and use a library called Web3 of JavaScript. Then you can use the code to interact with the Solidity. Maybe I will introduce them in week 7, maybe, yeah. How can we add value to fixed array? You can't add. You can make assignment of the fixed array. You can't add some value. Add the legends of the fixed array. If you want to make assignment of the fixed array, you can just do like this. If A is a fixed array, right? So you want to assignment for the second position of the A, then you can use the subscript here and equal, use an equal symbol to some value, I guess, if A is a uint array. Okay, there are too many questions. Maybe guys, I will see you next week. And if you guys have another questions, you can put it on the Google Doc, then I will check and answer that. So maybe this is the end of this week sharing and masterclass. Thank you guys for listening.